In this section, we'll focus on LDAP-related features. We'll be using a SUSE Enterprise 10 box, and we'll log in as the non-privileged user Linux CBT. However, when we're making changes that require super user privileges, we'll obviously at that point either SU in as root or SSH into the target system as root. Now, LDAP provides many features. First and foremost, it is a directory, lightweight directory. And directory servers excel at storing information that's read often as opposed to information that's read and written, as we have seen with databases or know about with relational databases. So we use LDAP to store primarily read-only information. Again, it's obviously updatable. There are commands for adding, modifying, removing, and changing the lightweight directory database, but it's a primarily read-only protocol. So it's great, or it excels at serving information that doesn't change often. Now let's open a shell and begin documenting these features that apply to LDAP servers across the board regardless of the distribution you're working on. We'll also include the distributions and Linuxes and Unices that we'll be focusing on. Let's launch a window, a gedit window, and we've got an LDAP subdirectory already created where we'll store our notes. So let's save this document in our LDAP subdirectory. So let's browse to other folders and label it LDAP edition notes. And it's a text file, and it's included in your docs subdirectory with this edition of Linux CBT. So we're discussing general features of LDAP, or Lightweight Directory Access Protocol, and there are many of them. Perhaps the most important feature is that it's a centralized directory of information. So centralized directory of useful information. Useful information could include logins, for example, as well as contact information, as well as any sort of information that is derived from schemas that are LDAP compliant, can be stored within an LDAP directory. But we quite often find LDAP in use with respect to user authentication, such as logging into your Linux system or authenticating to your Windows network using Active Directory, or authenticating via eDirectory, which is a Novell product. These are all LDAP-centered products, but at the core of it all is the Lightweight Directory Access Protocol. So it's a centralized directory of useful information, and in that it provides what is called a directory information tree, which can often look like a DNS hierarchy, with dot being the root of DNS and the sublevels or second, third, and so on levels falling beneath the dot or root level of the tree. So it provides a DIT, or a directory information tree, and this directory information tree is created by you, and it should mimic the requirements of your organization. So you may have at the top of the directory information tree the name of the domain that you're serving, which we'll create as linuxcbt.internal, and beneath it one or more organizational units which will be used to store information that's pertinent to your LDAP environment. So it provides it, and it's basically a hierarchy which resembles DNS in some respects of information or data. We should also note, before we move on to other features, that the objects that are in your directory are unique. Every object has a unique name. So objects within the directory are unique. And they may have many attributes, or simply attributes, one or more attributes. Attributes being, of course, equivalent to fields in databases. So let's just recap. LDAP allows us, as one of its most important features, the flexibility of centralizing useful information. So it's a centralized directory of useful information. And we'll include parentheses to note items such as user accounts, contacts, mail info, etc. Whatever your organization considers to be useful, and if you can construct a directory information tree based on one or more schemas supported by LDAP, you'll be able to then store that information in LDAP with little trouble. And it does so, LDAP, regardless of the stripe of LDAP, whether it's implemented by Red Hat, Solaris, AIX, HP, you name it. It provides a directory information tree, a hierarchy of data, and in some regards it resembles DNS, because with DNS we have a root and we have various subcontainers such as .com, .org, .net, .mil, .co.uk, .country code, so on and so forth. Those containers are analogous to organizational units. Let's just expound upon this for a moment. So A1, DNS provides a top level, and we'll place it in between single quotes, a top level dot, which is the root of the tree or hierarchy. And A2, DNS provides sublevel containers, i.e. .com, .net, .co.uk, etc. So when comparing DNS to LDAP, we look at a top level and sublevels, and of course beneath each sublevel there are third, fourth, fifth, and so on levels that are controlled by and administered by the administrators of given entities. Objects within the directory tree, as we've mentioned, are unique and may have attributes. Attributes are fields. Let's just make that clear. Just like in a relational database context, attributes are fields. They're one and the same. They're simply named attributes. It's a fancier name. It's a classier name. It's a more sophisticated name. But attributes basically mean fields. So in a simple contact database where you have, let's say, first name, last name, middle initial, SSN, address 1, address 2, city, state, zip, those are all attributes. And of course attributes have constraints, meaning certain attributes are restricted to certain types of values. So you may find, for example, that a numeric field should only contain numeric items as opposed to alpha and numeric items, and other constraints. But generally speaking, LDAP attributes are open unless the schema restricts the attributes. So we've listed some of the reasons why LDAP, being a centralized directory, is its most important feature. Again, it allows us to consult one or more housers or repositories or maintainers of this centralized directory, and the directory mimics DNS. We should also note LDAP DIT typically resembles the following: domain, then OUs. Or to be more specific, the name of the domain that you have set up as your top level or hierarchy. And that's referred to as a DC. So DC, then OUs. There's generally one DC, one domain, one top level of the hierarchy, followed by one or more OUs. The OUs then contain the objects that are to be referenced, such as user accounts, mail attributes, and other items that are stored within the LDAP database. Let's move on to some other features. We'll dig into each of these features or drill down as we move forward in our studies. Again, this is just a feature section so that you know the capabilities of LDAP. As we've mentioned, LDAP is optimized for reads. But that doesn't mean you cannot write to it. You certainly can. So note, you certainly can write to LDAP objects. After all, you have to set up your directory information tree and populate it in order for the database to be useful. So you can write to it, but it is optimized for reads. In other words, more reads, fewer writes. Let's move on. Another important feature with LDAP, it provides built-in redundancy. For example, you may implement primary, secondary, tertiary, etc. servers. The primary server houses the copy of the database that's updated. Secondary, tertiary, etc. house copies of the database, and the replication takes place between the primary, secondary, tertiary, and so on servers, all built in within LDAP. And we'll look at setting up a redundant configuration later on in a dedicated section. So we can configure our directory across multiple hosts, but the writing takes place on the primary, with changes being replicated to one or more partners. So writes take place on the primary, and changes are replicated to one or more partners for a given directory information tree, which means, of course, if one or more of your servers goes down, if there is a surviving member, that surviving member can serve the LDAP directory tree to connecting clients, whether they come from Linux, Unix, Windows, or an email application that supports LDAP is irrelevant, so long as there is a surviving member which can serve the directory information tree. You will be able to access the directory information tree and all of its objects. So it supports built-in redundant configuration, and we'll look at that later on. We'll just mention once more, as although we have, but more formally, that the namespace provided by LDAP is very similar to DNS. And we'll list as an IE, as an example, some LDAP terminology. DC is equal to the name of the domain that we'll be creating. DC is equal to its suffix, internal. Whenever we do anything domain-wise within the Linux CBT classroom environment, we tend to use a suffix .internal, which doesn't exist on the internet, as opposed to com, org, net, etc., which are routable on the net. So if we're doing a DNS training session, we'll use Linux CBT.internal, or just covering DNS, LDAP, or any technology, just naming the hosts altogether. Within the classroom environment or within your organization's environment, it makes sense to use a non-routable domain, unless, of course, you're tying your internal hosts to your external name. So this definition, DC equals Linux CBT, comma, DC equals internal, defines the domain, the namespace that is to be served by the LDAP server. And this is quite similar to DNS. DNS simply looks like the following: linuxcbt.internal. .internal being the top level right beneath the final dot, of course, and second level being Linux CBT. Well, again, when we define our namespace, the container, the domain that all LDAP clients will authenticate against searching for objects such as user accounts, etc., it will consult the Linux CBT, DC equals Linux CBT, comma, DC equals internal domain. And also when you authenticate from the command line, let's say to add, modify, delete items from the LDAP directory, you'll find that you'll have to authenticate using the fully qualified, again, another DNS terminology, the fully qualified LDAP domain including the user. So you'll use a common name, such as administrator, DC equals Linux CBT, comma DC equals internal. So get used to this terminology, because within LDAP, this is specified quite often. Even if you're using a GUI tool, to authenticate to an LDAP directory tree, you must specify the fully qualified name, let's say, of the user, unless you connect anonymously. But even then, you still need to indicate the name of the domain. And we do so by using the DC attribute. This is a field. DC equals Linux CBT, comma, DC equals internal. This is the top level of our LDAP hierarchy that we'll create momentarily. Now let's move on to some other features. LDAP supports auth encryption of clear text auths, and these are authentications from clients, and it does so using LDAP secure on TCP port 636. Now this isn't the standard LDAP port, it is the TCP secured port 636, and this allows the authentication of LDAP clients to go encrypted, as opposed to the standard port 389, which transfers authentication requests to the LDAP directory in a clear text fashion. Now we'll spend most of our time using the 389 clear text port because we are in within a controlled environment. Then later on in the security section, when we're tightening up our configuration, we'll ensure that we have a self-signed key and have LDAP set up on TCP port 636 to encrypt communications between the connecting client, regardless of the client. Could be a GUI client, text-based client, you name it. At that point, the communications will be secured. And in addition to the LDAP secure port, which is the older methodology, but it's still supported by binding to TCP 636 and securing the communications over that port, LDAP supports Start TLS, which is a newer means of encrypting the transport layer. This encrypts everything, not just the authentication process, but the entire connection between the client and the server. And that's Start TLS, or Transport Layer Security. So when a client connects to the LDAP server can go into Start TLS mode if it's supported and if the client supports it. In other words, it's negotiated at connect time. This runs over the standard TCP port 389, which means for the firewalls in your environment, you'll have fewer ports to administer or fewer ports to open. So this happens over the regular LDAP port, TCP port 389. That's Start TLS, or Start Transport Layer Security, which secures the entire connection. So secures entire connection between the client and the server at a given point in time. But of course, it supposes that both the client and server support Start TLS. Now let's keep moving through our features. Another feature is that LDAP is extensible. Now, whenever technology is extensible, it simply means you can extend it. You can add features, extend the schema in this case with LDAP, tack on new features such as support for Start TLS, so on and so forth. With respect to LDAP, you're generally concerned about your ability to extend the schema so that you can store your data set. So it supports many attributes via schemas. And those schemas are stored if you've got a standard Linux install of OpenLDAP, or even a Unix install, a standard install, beneath etc OpenLDAP schema. This is where you'll find the schemas that are shipped with, or that comes with your version of OpenLDAP. And if you download additional schemas, useful schemas, or if you extend the schema yourself as an organization, you should place that schema within etc OpenLDAP schema and reference it wherever necessary in your configuration. So it is extensible. It allows us to stretch the schema. Yet another feature is that, and it's important to note, the data storage within LDAP is independent of LDAP itself. So data storage is independent of LDAP. However, there is a default storage engine, and that is DBM. So one of the prerequisites within a Linux environment is that you install DBM, which we'll be sure to do if you're using a utility such as YaST within SUSE or the RPM manager within Red Hat. Then the dependencies will be fulfilled automatically. But again, the data storage is independent of LDAP. In other words, what that means is Lightweight Directory Access Protocol is not a database backend. It's simply a technology, a framework for storing information, this hierarchical layout of your directory information tree, which includes a top-level domain, which sits atop the hierarchy, followed by one or more organizational units for storing your information. However that information is stored physically on the disk is dependent upon the technology compiled into your version of OpenLDAP. So it could be a back-end database such as MySQL or Oracle, or simply DBM. DBM is the default, however, and it does an excellent job of storing information pertaining to your directory information tree. So unless you have a specific need to use a data engine such as Oracle or MySQL, then the default DBM should suffice. And the default DBM places the files in your file system, which we'll take a look at once we have OpenLDAP up and running. Another feature, and there seems to be infinite features, but we'll cover just the key ones. We're wrapping up our feature set momentarily here. Another feature is that LDAP provides various administrative tools, various tools for administering the LDAP server. We've got a series of tools prefixed with SLAP or SLAP, so SLAP star. And we'll note that these are offline tools, offline or back-end tools. They're used to make changes to the LDAP environment when LDAP is not running. So keep that in mind. Use when LDAP is not running. So you've taken it down, let's say you've rebooted your system to run level 1 single user mode with no network connections, at which point you use the SLAP star tools to administer the database. And by administering the database, we mean, for example, modifying the attributes that are there. Let's say you have a user account, you need to change some details regarding the user account, or let's say you need to make wholesale changes across the board and want to do it offline. Then you could use the SLAP tools. However, in a perfect world, we'd do things offline and bring the server back online. But in a world that's more indicative of the world we live in, we also need tools that provide various online capabilities. So not only do we have access to updating the LDAP directory information tree offline, but we certainly can online. So again, provides various tools. And these tools are named slightly differently. These are the LDAP star tools. These tools are used to administer the server online, and you should use them basically for daily administrative tasks. Again, the tools include adding, modifying, deleting, and so on. Items within or entries within your directory information tree. Yet another feature is that LDAP provides, again, this all pertains to OpenLDAP, so if you're using a proprietary LDAP, which may or may not have modifications, you'll need to double check what we're telling you about OpenLDAP versus a proprietary form. There are proprietary forms that are largely OpenLDAP based, but different enough where you'd have to consult the vendor's manual to see what those differences are. So, separate binaries are provided for the LDAP daemon versus the replication daemon. So separate binaries for LDAP daemon, and it's called slapd, and replication. And this binary is called slurpd. So when you set up your LDAP environment, if you execute ps-ef or ps-aux, and you see, for example, slapd as well as slurpd, know that slapd is the LDAP daemon running on your host, or whatever host you've executed ps on, whereas slurpd is the replication daemon, which looks for changes in the LDAP database to replicate to replication partners, one or more. As we've mentioned as one of the key features, the fact that you can set up LDAP server in a redundant configuration. While the slurpd daemon runs on the primary, it also searches the database files for changes, and when it finds changes, it replicates those changes over to one or more LDAP servers. So if you've got primary, secondary, tertiary, slurpd will check in every now and then, and it's quite frequent, and it copies those changes over to the secondary, tertiary, and so on servers, so that when clients, LDAP clients, authenticate to the LDAP server that's least busy or responds the quickest, or the one that has survived a failure, it has in all likelihood the latest information. The replication interval is small enough, along the lines of 5 seconds, and is tweakable, where you should have an accurate reflection of, or an accurate account of, the directory information tree at any given time. Again, if you think of LDAP as a database that should not be modified very frequently like a MySQL or Oracle database, then the interval 5 seconds or even 10 seconds or whatever we set it to should suffice, considering that the database shouldn't change frequently. For example, if you convert, which we'll show you later on, your user authentication of your Linux and Unix servers from etc password, which is a local flat file, to LDAP, you will migrate the users from the local etc password database file, one or more, from one or more systems, into LDAP using tools that you can download from the internet. And that information shouldn't change frequently, unless of course you're running a very, very busy system, in which case it may make sense to run LDAP on the same system that's referenced or changed frequently, and to perhaps tweak the frequency of the replication. But nonetheless, user account information shouldn't change too frequently to cause the 5-second default replication interval to be of any concern. So let's just quickly look at the features again. LDAP is a centralized directory. Its acronym means Lightweight Directory Access Protocol. It's called Lightweight Directory Access Protocol because, unlike a DBMS such as Oracle MySQL and so on, it is not optimized for frequent reads and writes, but rather for frequent reads. It presents the information to the connecting client in a hierarchical fashion, regardless of the vendor. So if you connect from a Netscape email program, or from an LDAP browser, such as the one included with SUSE Linux, or just using a plain old LDAP text-based tool such as LDAP Modify, you're basically connecting to a hierarchy known as the directory information tree, and you'll authenticate against that hierarchy using the suffix that is the domain, that is one and the same with the domain, which we talk about below, the namespace. So LDAP provides a DIT, which you need to become familiar with to know where objects are within the tree, and that tree resembles DNS. Objects within that directory information tree are unique. They have unique names. For example, an object in the OU people is distinct from an object, a similarly named object in the user's OU, because they have distinct names. And those are the distinguishing names, or DNs, that make those individual items unique. Again, it's optimized for reads, not writes, but you can write to it using the tools provided. It supports a redundant configuration using slapd and slurpd. Slapd is the default LDAP server. Slurpd handles the changes and replicates them to replication partners. Again, we'll reiterate that if you know how DNS works, you're well on your way to understanding how LDAP is laid out. The namespaces are very, very similar. Top-level domain, granted there's some additional terminology, DC equals, DC equals. This is just a slightly different way of presenting the name and the various attributes associated with a given name, but nonetheless, if you know that DC as an attribute means the domain, in this case the one we'll be creating, linuxcbt.internal, then you can equate it to the DNS linuxcbt.internal. It also helps if you're new to LDAP, or even if you're a seasoned LDAP user or administrator, to name your LDAP DIT based on your internal and or external DNS layout. LDAP supports auth encryption. We did mention below that it's extensible, so it supports auth as well as start TLS encryption, which we'll look at later on. It's extensible, so in addition to the schemas that are included, we can extend personally if we're familiar enough, or download schemas that have been written by other folks on the net to suit our needs. But the core schemas that come with OpenLDAP typically suffice. The data storage is independent of LDAP, but it defaults to DBM. Again, that means if you're considering storing your LDAP directory information tree in a relational database such as Oracle or MySQL, you're free to do so. You simply need to make some changes to your OpenLDAP, such as compiling it for Oracle/MySQL support, and then you're okay. There are tools for offline SLAP star tools and online administration LDAP star tools. So you can make changes when the server is up and running using the LDAP star tools, such as LDAP modify, LDAP add, LDAP remove, or when the server is offline, SLAP star tools. There are separate binaries for the main daemon, the LDAP daemon, and the replication daemon. They are slapd and slurpd respectively. Now with that said, we're going to move on to showing you how to set up LDAP on our SUSE 10 box, then our Red Hat box, plus our Solaris box, and we will look at the core schema and talk about various issues regarding getting our information tree up and running.